The search for habitable planets within our solar system is a topic of great interest. Today, we will compare the unique challenges and prospects for human habitation on Venus and Mars. Venus and Mars are two neighboring planets with vastly different characteristics, making them ideal for a comparative habitability analysis. We will be comparing them on factors such as atmospheres, surface conditions, water and resources, and finally, their terraforming possibilities. Let's begin by comparing these two absolute titans' atmospheres. Venus has a thick, toxic atmosphere, while Mars has a thin atmosphere, mostly composed of carbon dioxide. These differences have significant impacts on habitability. Venus's atmosphere is primarily composed of carbon dioxide, with clouds of sulfuric acid that create a greenhouse effect, leading to surface temperatures of up to 900 degrees Fahrenheit. Hearing that already makes me think Mars will win this no difficulty. In contrast, Mars' atmosphere is thin, with a surface pressure less than 1% of Earth's, and is mostly composed of carbon dioxide, already sounding like Earth. The surface conditions on Venus and Mars are a result of their proximity to the Sun and the composition of their atmospheres. Venus's thick atmosphere of heat-trapping carbon dioxide, nearly 100 times thicker than Earth's, contributes to its extreme surface temperatures. In contrast, Mars's thin atmosphere, only 1% the thickness of Earth's, and its distance from the Sun result in its cold and arid surface. The similarities and differences in the atmospheres of Venus and Mars, both being about 95% carbon dioxide, provide valuable insights into the contrasting surface conditions and the challenges they pose for human habitation. Water and resources. Mars has evidence of past water activity, with polar ice caps and subsurface water ice. In fact, Mars likely got its water from asteroids and comets that bombarded its surface. Conditions may have been right for the red planet to be habitable from 4.1 to 3 billion years ago, during which time life could have taken hold in global oceans, rivers, and lakes. However, the solar wind, charged particles from the Sun, stripped away the Martian atmosphere, causing all liquid water on the surface to evaporate into space, merge with minerals, or fade underground to become water ice. Today, the best bet for water resources on Mars is water ice, which can be found in the planet's northern and southern regions. With approximately 5 million cubic kilometers, 1.2 million cubic miles of ice at or near the surface. Venus, on the other hand, has no evidence of liquid water on its surface, but there is speculation that it may have had oceans in the past. The atmosphere of Venus has water vapor, just like Earth's atmosphere. However, the dense atmosphere and extreme surface conditions have made it difficult for water to exist in a liquid form on the planet's surface. The presence of water is a crucial factor for human colonization efforts, as it is essential for life and sustenance. Terraforming possibilities. Terraforming Venus. Reducing Venus's greenhouse gases and cooling the planet would be a significant challenge, as the dense atmosphere would make large-scale carbon capture and solar shades difficult to implement. There is a possibility of using a giant magnetic shield to reflect sunlight and reduce the planet's temperature. A wild idea to say the least. Another approach, proposed by Carl Sagan in 1961, involves the use of genetically engineered algae to fix nitrogen, which would help create a breathable atmosphere. Although these methods are theoretical and far from being practically achievable, they provide a glimpse into the potential strategies for terraforming Venus. Terraforming Mars. Mars terraforming would involve several steps, including thickening its atmosphere, raising its temperature, and introducing liquid water. One method for thickening Mars' atmosphere is through the use of terraforming technologies and greenhouse gas emissions. Mars has experienced dust storms that can cover the entire planet, which could potentially provide habitable environments. Expert opinions and speculation. Several experts argue that Venus, despite its extreme surface conditions, should be the initial target for a crewed mission to another planet, emphasizing the need to understand how humans can move into the universe. Venus's infernal surface conditions have led to the conclusion that it has been uninhabitable for at least 70% of its history, casting doubt on the planet's potential habitability. However, a renewed scientific interest in understanding how and why a planet so similar to Earth in size, mass, and distance from the Sun ended up with infernal surface conditions has led to new proposals for missions to Venus as part of NASA's Discovery program. On Mars, scientists and engineers are exploring potential solutions for human survival, such as building habitats underground, using life support systems, and extracting water from ice at the planet's poles or in the ground. Several potential methods for the terraforming of Mars may be within humanity's technological capabilities. Although the economic and technical challenges are significant, NASA's Mars rovers have found evidence of ancient water flows, leading to speculation that Mars could once have supported life. In summary, the potential for space colonization and the concept of permanent human habitation outside of Earth is becoming less science fiction and more a potential reality, with Mars being a focal point for future human exploration and potential habitation. However, both planets are still considered to be uninhabitable for humans, and further research and exploration are needed to unravel the mysteries of these two planets. So, keep your spacesuits off for now and enjoy some SciVenture videos.